What if the recipe for life doesn't require water, but poison? Titan is the only other body in the solar system where rain falls and rivers flow, yet its hydrology is a chemical nightmare of liquid methane and electrified ground. But this toxicity creates a paradox that haunts astrobiologists. Could a world made of toxic fuel actually harbor life? To find the answer, we must abandon everything we know about biology on Earth and descend into a place where the air is fuel and the cold is absolute, at 209 Titan, Earth's toxic twin. But what exactly is waiting for us beneath that crushing opaque haze? To understand this world, we must follow the path of descent. The moment a spacecraft pierces the upper atmosphere, the familiar black of space doesn't fade into blue. It dissolves into a suffocating monochromatic orange. This is the Titanian haze, a global shroud of smog that extends hundreds of kilometers above the surface. But this isn't just fog, it is the exhaust of a planetary engine. High in the stratosphere, ultraviolet radiation from the distant sun is smashing nitrogen and methane molecules apart, triggering a violent chain of photochemistry. These fragments collide and fuse, synthesizing complex organic polymers called tholins, essentially plastic dust. On Titan, it doesn't just rain liquid, it snows petrochemicals. As the probe sinks deeper, the light begins to fail. The haze is so thick that it scatters sunlight in every direction, erasing all shadows. There is no true day here, only a perpetual diffuse twilight that mimics a stormy evening on Earth. But the most immediate sensation hitting the sensors is pressure. By the time we reach the surface, the atmospheric pressure reads 1.45 bars, roughly 50% heavier than Earth's. It is the equivalent of swimming 15 meters underwater. The air here is dense, viscous, and heavy. An astronaut standing on the surface in a thermal suit would not need a pressurized helmet to keep their blood from boiling, unlike on Mars or the Moon. They would feel the atmosphere pressing against them, a physical weight wrapping around the body like a heavy blanket. And if the seal of a helmet were cracked, chemical analysis reveals the air would smell of a terrifying chemistry lab, the sweet gasoline stench of benzene mixed with the bitter almond bite of hydrogen cyanide. This is the air of Titan, a toxic, crushing ocean of gas that creates the most aerodynamically strange environment in the solar system. On the surface, a human body would feel confusingly light despite the crushing air pressure. Titan's gravity is weak, only about 14% of Earth's, even less than our own Moon's gravity. This creates a physics paradox that exists nowhere else, a lightweight object moving through a heavyweight fluid. This unique combination of low gravity and high atmospheric density unlocks a superpower that remains a dream on Earth: human-powered flight. The air is so thick that it provides 4 times the aerodynamic lift of Earth's atmosphere. Calculations suggest that if an explorer were to strap a pair of artificial wings to their arms spanning just a few meters and run, the dense air would catch the fabric with immense force. With a few strong flaps, their feet would leave the ground. A human wouldn't just glide, they could actively fly, soaring over the hydrocarbon dunes with the ease of a bird. But this silence is deceptive. In 2005, when the Huygens probe became the first and only machine to land on this alien world, it recorded the sound of Titan's winds during its descent. It wasn't a howl, but a low, ghostly, rushing noise, the sound of a thick atmosphere, moving sluggishly but with unstoppable momentum. Because the air is denser, sound waves travel faster and carry more energy here. Acoustic models suggest a whisper on Titan would carry for huge distances, and the wind, even at low speeds, would push against an observer with the force of a gale. It is a world where the air itself feels like a physical presence, a medium that life doesn't just breathe, but moves through. Upon landing on soil that feels soft and wet like damp clay, we realize the sky isn't the only thing that mimics Earth while betraying it. The ground is saturated. The air is humid, not with water vapor, but with fuel. The orange twilight above is about to give way to something even stranger: the weather. As the orange twilight deepens, the humidity rises. But this is not the humidity of a tropical rainforest. It is the saturation of a fuel tank. On Titan, the laws of thermodynamics have conspired to create a perfect alien mirror of Earth's hydrology. It is the only other world in the solar system possessing a triple point, a precise temperature and pressure, where a substance can exist simultaneously as a gas, a liquid, and a solid. On Earth, that substance is water. On Titan, at 291 degrees, it is methane. The cycle begins in the upper atmosphere, where methane evaporates from the surface, creating vast invisible reservoirs of potential energy. As these vapors rise and cool, they condense into clouds not of white water vapor, but of dense hydrocarbon smog. When the saturation point is reached, the sky opens up. But a rainstorm on Titan is a spectacle of physics that defies human intuition. On Earth, raindrops fall rapidly, driven by strong gravity and cutting through thin air. On Titan, the gravity is weak and the atmosphere is thick as molasses. This combination drastically lowers the terminal velocity of falling objects. The raindrops here grow to massive sizes, twice as large as terrestrial rain, held together by the low surface tension of liquid methane. When they fall, they do not plummet. They drift. Imagine a storm where huge globules of liquid fuel descend in slow motion, floating down like feathers, taking their time to reach the ground. When this rain of liquid fuel finally strikes the surface, it doesn't splatter violently. It accumulates. It flows. It carves the landscape with the same relentless persistence as water on Earth. Radar scans have revealed extensive networks of river channels, winding canyons, and broad deltas, all sculpted by the flow of liquid natural gas. These rivers of fuel rush across the frozen bedrock, which is actually water ice, frozen so hard it acts like granite, carrying eroded sediments downstream. They are the arteries of Titan, transporting energy and material from the highlands to the vast reservoirs waiting at the poles. These rivers eventually drain into the Maria, the great seas of Titan. The largest of these, Kraken Mare, is a monster of the deep north, sprawling over an area larger than Earth's Caspian Sea. Standing on its shore, you would look out over a vast expanse of dark, oily liquid. It is a literal ocean of liquefied natural gas, a reservoir of chemical energy so immense that it exceeds Earth's entire proven oil and gas reserves by hundreds of times. But this ocean is not merely a static pool of fuel. It is dynamic, restless, and deeply mysterious. Because methane is transparent to certain wavelengths of light, looking down into Kraken Mare would be like looking into a deep black mirror. And beneath that surface, something strange is happening. During the Cassini mission, radar sweeps of the northern seas detected bright features that defied explanation. In Ligea Mare, the second largest sea, astronomers watched as islands, seemingly materialized out of nowhere, persisted for weeks or months, and then vanished without a trace. These were not solid landmasses sinking into the deep. They were transient phenomena that science is still struggling to decode. The leading theory suggests a violent fizzy reaction. Titan's seas are rich in dissolved nitrogen. When the seasons change and temperatures fluctuate slightly, or when mixing currents disturb the depths, this nitrogen may suddenly exsolve, bubbling out of the liquid like a shaken soda can. These magic islands might be massive swarms of nitrogen bubbles frothing on the surface, creating a temporary phantom landmass that reflects radar before popping and dissolving back into the black depths. Alternatively, they could be floating solids, honeycomb ice made of frozen hydrocarbons that drift like icebergs until they become saturated and sink. Whatever they are, they prove that Titan's hydrology is alive. It is a churning, bubbling, evolving system where the line between liquid and gas is constantly blurred. The water here is flammable, the ice burns, and the islands are ghosts. And as the waves of liquid ethane lap against the shore, they deposit not sand, but something far more complex, a dark organic grit that leads us out of the liquid abyss and onto the solid electric ground. Leaving the alien coastlines of the north, we move toward the equator, where the liquid methane dries up, and the landscape transforms into something even more disorienting. Stretching across vast regions like Shangri-La are massive, dark seas of dunes. They rise up to 100 meters in height and run parallel to each other for hundreds of kilometers, mimicking the great sand seas of the Namib Desert on Earth. But if you were to kneel down and pick up a handful of this sand, your senses would scream that something is wrong. This is not silica, it is not rock ground down by water and time. These grains are the final resting place of the orange snow we witnessed in the upper atmosphere. They are pure solid hydrocarbons tholins that have clumped together over aeons. You are standing in a desert made of coarse, dark plastic. The physics of these dunes is driven by a force that is merely a nuisance on Earth, but a geological architect on Titan static electricity. Because the atmosphere is dry and the hydrocarbon grains are perfect insulators, the friction of the wind creates a massive triboelectric charge. The sand here doesn't just pile up, it clings. The particles are sticky, clumping together like electrified styrofoam or damp snow. Walking across these dunes would be a struggle against friction and cohesion. The ground would feel spongy and resistant, grabbing at your boots with every step. The wind, though, blowing slowly near the surface, pushes these charged particles with ease due to the low gravity and high atmospheric density. It is a landscape of electric plastic, a place where the geology acts less like shifting sand and more like a crawling living skin constantly rearranging itself under the faint amber light. This electrified terrain is treacherous for wheeled rovers, which would likely become bogged down in the sticky charged drifts. To explore this world, humanity has had to evolve its engineering. We cannot drive here, we must fly. In 2034, a new detective will arrive on these shores, NASA's Dragonfly. It is not a rover, but a nuclear-powered dual quadcopter, a drone the size of a car. Taking advantage of Titan's thick air-low gravity physics, Dragonfly will hop from location to location, sampling the chemistry of the dunes and the ice. It is the first machine designed to hunt for answers in two distinct geological crime scenes: the impact crater Selk, where ancient liquid water might have mixed with organics, and the potential sources of Titan's mysterious atmosphere. This brings us to the greatest unsolved mystery of Titan's geology. By all calculations, the methane in the atmosphere should have been destroyed by sunlight, millions of years ago broken down into the tholins that now form the dunes. The fact that the sky is still filled with methane means something is replenishing it from below. The planet is breathing fuel. The smoking gun for this replenishment lies in features like Sotra Patera. It looks like a volcano with a deep pit and a soaring peak, but it does not spew molten rock. It is a cryovolcano. When it erupts, it vomits forth a slurry of cryolava, a mixture of water and ammonia, chilled to slush, but kept liquid by the antifreeze properties of the ammonia. This eruption is not a fiery explosion, but a slow heaving release of pressurized volatiles from the deep. As this icy magma breaches the surface, it releases trapped methane gas, recharging the atmosphere and keeping the cycle alive. It is the heartbeat of a geologically active world, proving that Titan is not a frozen relic, but a dynamic engine that recycles its own crust and atmosphere. But the presence of ammonia and water spewing from the depths suggests something even more profound. The volcano is just a vent. The real story lies in the reservoir beneath it. As we gaze upon the alien lakes of Titan, we face the most profound barrier in the search for extraterrestrial life: our own biological bias. For decades, astronomers have followed a single mantra: follow the water. We define the habitable zone, the Goldilocks region around a star, solely by the ability of a planet to sustain liquid water on its surface. By this definition, Titan is a graveyard. It is located far beyond the frost line, deep in the cryovacuum of the outer solar system, where the sun is a cold, distant spark. At 290 degrees Celsius, water on Titan is not a solvent. It is a mineral as hard and geologically inert as granite. But Titan forces us to confront a disturbing question: is water truly unique, or is it just the solvent we happen to evolve in? From a chemical perspective, liquid methane is a nightmare for terrestrial biology. Water is a polar solvent. Its molecules have a positive and negative side, acting like tiny magnets that can dissolve salts, fold proteins, and hold DNA together. Methane is nonpolar. It creates a chemically neutral environment where the building blocks of Earth life would simply refuse to interact, or worse, fall apart. If you dropped a human cell into Kraken Mare, it wouldn't just freeze. Its membrane, the lipid bilayer that holds the machinery of life together, would fail to function entirely. In a non-polar ocean, the lipids would not form a protective bubble. They would dissolve or clump uselessly. However, Titan offers a hidden sanctuary for the traditionalists. Radar and gravity data from Cassini suggest that deep beneath the crust of organic dunes and methane rivers, there lies a global subsurface ocean. But this is not the clean blue ocean of Earth. It is a dark, pressurized slurry of water mixed with ammonia. The ammonia acts as a potent antifreeze, depressing the freezing point and allowing liquid water to exist even in the cryo-darkness. In this deep abyss cut off from the sun and the surface life as we know it, water-based DNA encoded could theoretically survive huddled around hydrothermal vents that spew heat from the moon's tidal flexing. Yet this deep biosphere is not the true prize of Titan. The real revolution lies not in the hidden familiar, but in the exposed alien. The surface of Titan is awash in liquid energy and complex organics. It has rain rivers and sunlight. It has all the requirements for a biosphere except the water. If life exists up here in the orange twilight, it cannot follow the rules of Earth. It must be a form of life that has abandoned water entirely, a biology built on a completely different chapter of the textbook. Enter the azotosome. In 2015, chemical engineers at Cornell University modeled a theoretical cell membrane that could function in the harsh, non-polar oceans of Titan. They called it the azotosome, derived from the French word azote, meaning nitrogen. This is the concept of Life 2.0, a biology that does not fight the cold, but embraces it. On Earth, our cell membranes are liposomes, bubbles of fat that keep water in and chaos out. They work because their hydrophobic tails hate water, and their hydrophilic heads love it. On Titan, the rules of chemistry must be inverted. An azotosome would be an inverted membrane. Its chemical tails would stick outward to interact with the methane ocean, while its heads would point inward to create a protected, isolated pocket of existence. This structure would remain flexible and stable, even at temperatures that would shatter a human cell like glass. The most shocking part of this hypothesis is the raw material required to build it, vinyl cyanide, also known as acrylonitrile. On Earth, cyanide is a deadly poison. On Titan, it may be the brick and mortar of life. The Atacama, a large millimeter-submillimeter array known as ALMA, one of the most powerful telescope networks on Earth, peered into Titan's atmosphere and detected vast stratospheric clouds of vinyl cyanide. The data suggests that enough of this material rains down on Kraken Mare to create 10 million cells per cubic centimeter. The plastic desert and the methane ocean are teeming with the exact ingredients needed to build these inverted cells. So what would this life look like? It wouldn't be green and it wouldn't breathe oxygen. It would likely be a methanogen on steroids, inhaling hydrogen gas from the atmosphere, eating the acetylene that falls like manna from the smog, and exhaling methane back into the cycle. It would be a creature of pure chemistry, operating at a metabolic pace far slower than ours, living in a slow-motion world of frigid liquids. This possibility reframes Titan from a toxic wasteland into the ultimate test of the thermodynamic imperative. This physical law suggests that life is not a lucky accident, but a mechanism the universe invents to dissipate energy more efficiently. Wherever there is a flow of energy like the sunlight hitting Titan's atmosphere, matter organizes itself to consume that energy. On Earth, it built trees and algae. On Titan, it may have built azotosomes. We are left with a staggering duality. Titan might be a two-floor biosphere. Down in the basement in the dark ammonia ocean, water-based life might cling to existence resembling the microbes of Earth. But up in the penthouse on the surface of the methane seas, a weird inverted biology might be thriving in the open. If we find life here, life that uses plastic for skin and liquid methane for blood, it will prove that biology is not a miracle unique to water, but a universal, inevitable outcome of chemistry. As we step back from the edge of the methane seas and ascend through the orange haze, Titan leaves us with a realization that is both terrifying and hopeful. For centuries, we have looked at the universe through a single lens, searching for reflections of ourselves. We hunted for blue oceans, green continents, and oxygen-rich skies, assuming that the recipe for life has only one set of ingredients. Titan shatters that assumption. It proves that a world can be active, dynamic, and geologically alive while being chemically toxic to everything we know. Titan represents the most critical experiment in the history of science. Currently, biology faces the N-1 problem. We have only one example of life Earth's. We do not know if our biology is the universal standard or a cosmic fluke. Titan offers the chance to find N-2. If the Dragonfly mission lands in the Shangri-La dunes in 2034 and finds nothing but sterile plastic dust, Titan will still be invaluable. It will remain a frozen museum, a pristine snapshot of what the solar system looked like before life took hold, a laboratory of almost. It will show us the limits of chemistry, the point where complexity hits a wall and fails to become biology. But consider the alternative. If we find a single microbe in those hydrocarbon lakes, a simple, sluggish, methane-eating cell with an inverted membrane, the implications would be instantaneous and absolute. It would mean that the origin of life is not a miracle, but a law. It would confirm the thermodynamic imperative. The idea that the universe inherently seeks to create complex structures to dissipate energy. It would mean that life is not fragile or rare, but stubborn and inevitable, emerging wherever energy flows and liquids pool. If life can start twice in two completely different chemical environments within the same solar system, then the universe is not just habitable, it is crowded. It would mean that the Goldilocks zone is not a narrow ring around a star, but a vast spectrum of possibilities, ranging from boiling steam to freezing nitrogen. Titan forces us to abandon our geocentric arrogance. It asks us to look at a dark, freezing moon, covered in smog and sea potential. It reminds us that nature is the ultimate alchemist, capable of transmuting the deadliest poisons into the building blocks of existence. We have spent decades scanning the stars for water, convinced it is the only elixir of life. But Titan whispers a different truth from the outer dark. The universe might be swimming in fuel, and we are just beginning to learn how to swim.